Good morning, students. In last class we have done about the d block elements. D block elements means those elements in which the last electron enters in d orbital of their respective penultimate cell are called d block elements, and they have d block elements are present in between group number 3 to 12, and they have the general valence cell configuration n-1 d1 to 10 and s0 to 2. Now you have to know about the properties of d block elements. The properties are very important. Number one, these are hard, hard metal with ductility and malleability character. So these d block elements all are metals, and they are very hard metal. You know, iron, manganese, these are hard metal, and they have the ductility and malleability property. I mean, you can make thin sheet, you can make wire from these metals. And number two, they have high boiling point and melting point. Since they are hard and their metallic bondings are very strong, and that is why they have very high boiling point and melting point. Number three, they are good conductors of heat and electricity. They are good conductor of heat and electricity. Another property which is very important, they can show variable valency. This is one of the important property of d block elements. They show variable valency. I mean, normally for general element the valency is fixed. For example, sodium valency is 1, magnesium valency is 2, their valency is fixed. But d block elements, I mean the transition metals, they can show variable valency. And why they show variable valency? As you have got in the valence cell, they contain d orbital in the penultimate cell and s orbital in the valence cell. Now when they involve in bonding formation, the electron from s orbital and the electron from d orbital both can involve in the bonding formation. I mean, if the element want to release electron, they can release electron from this s orbital also, from this d orbital also, and that is why they can show variable valency. In case of normal elements, they can release a fixed number of electron, but in case of transition metal, for example, if you consider iron is 26, its electronic configuration is argon 3d6 4s2. If iron release electron, it can release electron from 4s also, it can release electron from 3d also, and that is why iron can release 2 electron or iron can release 3 electron also to make it half filled. When it release 2 electron, then iron become 2 plus, electronic configuration becomes argon 3d6, I mean electron release from s. When iron is 3 plus, then the electronic configuration become argon, then it goes to 3d5. I mean, it can release the electron from s also, from d also, and that is why they can show variable valency. Actually, between this 3d and 4s orbital, the energy difference is very small, and due to a less energy difference, by applying same amount of energy, you can release electron from s also, you can release electron from d also. So since both electrons from s and d orbital involve in bonding formation, That is why they can show variable valency. For example, iron can show valency 2 also, it can show valency 3 also. Due to this character, this Fe2 plus is called ferrous, Fe3 plus is called ferric. Ferric is stable due to presence of half-filled d orbital. So like iron, as iron shows 2 and 3 valency, other elements also can show variable valency because they can release electron from both s and d orbital. So this is one of the important property of this d block elements. Number 5, they can form colored compounds. They can form colored compounds. Why they can form colored compounds? I'll tell you later. Before that, if a compound contain transition metal, if a compound contain d block elements, that type of compounds are always colored. For example, iron compounds always green color, copper compounds blue color. So every d block elements produce colored compounds. And why they form colored compounds? It is due to dd electronic transition of metals. What is dd electronic transition? As you know, the last electron of transition metal enters in d orbital. Suppose this is 3d orbital and someone contain 1 electron in 3d. For example, scandium. You know scandium 21, its electronic configuration is argon 4s2 3d1. It contains 1 electron in d. This electron is present in this d. This electron can jump from this orbital to this orbital, or it can jump from this to this orbital because they have similar energy. So automatically the electron jumps from one d orbital to another d orbital, and that is called dd electronic transition. And due to this dd electronic transition, they produce colored compounds. But if an element contain completely filled d orbital like this, 10 electrons present in d, then there will be no dd electronic transition, and that is why those elements which contain 3d10 configuration, that element always produce colorless compounds. For example, zinc, you know, zinc atomic number is 30. Due to presence of 30 atomic number, its electronic configuration 4s2 3d10. D contain completely filled orbital, and that is why completely filled electrons, and due to this completely filled electrons, this dd electronic transition is not possible, and that is why zinc compounds are always white. You don't get colored compounds for zinc. So except zinc, other elements are always produce colored compounds. Now, if d orbital is vacant, then also there is no dd electronic transition. Then also it become colorless one. So you will get the colorless compound only when d is completely filled up or d is completely vacant. But if d orbital contain 1 to 9 electron, then this type of dd electronic transition takes place, and due to this dd electronic transition, they form colored compounds. Scandium chloride. This is one of the compound. If someone asks you, this is a colored compound or colorless compounds, here transition metal is present, scandium. As I have told you, the compounds which contain transition metal, they are always colored. In scandium chloride, you know chlorine is always -1 charge. Here 3 chlorine, that means -3. So here scandium will be +3. Scandium contain +3 charge. So when scandium is neutral, then the configuration becomes argon 4s2 3d1. So scandium 3 plus means it release 3 electron. Electronic configuration become only argon. There is no d electron. D is totally vacant, and due to vacant d, it become colorless. dd electronic transition is not possible. That's why this compound is said to be colorless one.